Right, sorry about the colour by the way, it's just because it's getting late, so camera decides to tell me to shove off, but no, we're going to go on with the new video. In this video, what we're going to talk about is, we're just going to give you a bit of information on the trapezium rule for C4, Edexcel, whatever. The point of this video, I just wanted to make, it's more of a recap, to be honest, of the C2 trapezium rule, and I'm just going to go into things that I'm not sure 100% that I mentioned in the C2 video. Obviously I'm going to be recapping the law, what little bits of the law means, how to remember it, but I won't be going through any questions in this video. I'm going to save that for another video where I'm just going to do some past paper questions on this topic. I don't want to do some questions in this particular little video because I think it's kind of a short video really, to give you a bit of a break from watching them long videos. But I just wanted to sort of recap it, as I said, because there's nothing new in C4, especially that I found anyway, for Edexcel. I'm not 100% sure on any other exam boards if much changes, but there's really nothing changed. The only difference between this and the C2 trapezium rule is that obviously in the formulas for the trapezium rule for this C4 one is obviously the graphs are a little bit more advanced, shall we say, but considering the fact that you don't integrate the formulas, you just use a general rule, you know, there's nothing new really. It's just the shape of the graphs that might be a little bit more challenging, but it's not asking you to draw them, it's just asking you to integrate them. First off, I'll just remind you what trapezium rule is. So you might get a graph that looks something like this. This is, again, it's a C2 thing really, so you know, if you're familiar with the C2 one, or if you want, I think probably the C2 video is probably a bit more in depth than this because I'm assuming you know half of it anyway. Say we've got something like this. Say this is y equals some function of x, I'm going to call it g of x, and we get some limits to integrate it between. I'll call these a and b. Okay, and we're asked to integrate this little bit here. Now the trapezium rule, as it says, involves trapeziums. I know this will be obvious if you've done it before, which you should have done if you've got to this stage in Edexcel. If you haven't done trapezium rule before, I'd be a little bit concerned. So what we have here is a set of trapeziums, and then we can connect them up, and they have a little bit of sort of an underlying thing between the curves. So it's not perfect. They're very close, but they're not perfect. And each of these strips has exactly the same width. And now we call this width, the height of the... So we denote the difference in x between each, the width, as actually the height. Because if you actually look at it as a trapezium, which is something like this, isn't it? What we actually get is this bit here, the height, is actually the difference in the x values between each trapezium. So therefore we call h the difference in the x values between each one. So the height of each trapezium essentially. So that's why when we use h, which means the difference in x values, the width of each trapezium. So as I said, that's more of a C2 recap, nothing new there. So when we would integrate this, we couldn't just see this. Generally, this will be something like the square root of 4 take x, and you could integrate that. Now, I know I could hear some of you in the background probably saying, well, guess what? You could just simply do the reverse bracket rule of integration, where it's the integral of ax plus b to the power n is equal to ax plus b to the power of n plus 1 over n plus 1 times 1 over a plus c. And you'd be very correct, you could do that. However, generally they might even, they will be a bit more complicated than that. And you know, it wants the trapezium rule, so we're going to have to use, weirdly enough, the trapezium rule. So I wouldn't, if it says trapezium rule, don't try and work around it. I mean, I probably would end up doing that, something I'd do, but so don't feel bad, but you know, it's quite specific. Okay, so the formula, well, I'm just going to give it you, because I'm assuming you know it. So it's h over 2 because that's the height, and then that is times by the first one, so y0, plus the last one, yn, and that is plus 2 times the ones in between us. So it's y1 plus y2 plus y3, etc. And then to yn take 1. And then that's all times by h over 2. So that's the area under the graph there. Okay, so this y, what's this y business? Well, that'll be the first y value, the second y value, so that'll be the first, the second, third, and then this is the very first one, the very last one, and then the ones in between. So it's sort of, and then this h is the width of each strip over 2. If you generally will be told the width of each strip, so really it's just plugging numbers into a formula. It's nothing much more advanced than that. As I said, it's really just a recap of your C2 knowledge. Because you'll be given an equation. You might be given it in parametric form. Here's an equation for x and here's an equation for y. So then you just put your y values in there for each x value. Because obviously the y values of these are different. So that's why. And we can't use the x values because that's the width of the trapezium. So that's why there are y values there. So that's the last y value and your first y value. So they are y values, not x values. As I said, we can't use x values because that's the width of each strip. So that'd be quite, wouldn't be really relevant to this question. So that's what you do. As I said, that is really C2 trapezium rules. Nothing new there at all. Apart from the graphs, it might look a bit different. Okay, so the next part that I want to talk about, as I said, something we've already talked about in C2, etc., etc. Just want to mention something called overestimation and underestimation, and when it occurs when doing something like this. Because although trapezium rule is very good, there's a reason why we don't use it for ones where we can use we can use what we'd normally use to find the correct value. So when we've got this curve, say a curve like this, and we use a trapeziums, so what we generally have, say this was that was your y-axis, and then it was your x-axis, and then this was your curve y equals f of x, a function of x. Obviously this is going to be like negative x squared plus 2, but I'm not interested in that. We're told to integrate it between a here and b again. And at the same points before, just 2 points. You would generally work something like this. So you'd have equal length trapeziums. Mine's not very perfect because I'm trying to do it quite quickly because it's nothing too much on this topic. And if you zoomed in on one of them trapeziums, or if you just pick one of them instead of splitting them all up, you'd end up with something like this. So it's the same as zooming in, really. So if I draw that again, so it's the same thing, even though it doesn't look quite the same. What you'd end up with something like this. If you zoomed in, if you made it a lot bigger, you'd end up with this area at the top, where all these trapeziums, yes, they wouldn't be level, but this is just to emphasise it. You'd have this bit here that I'm colouring in, or shading in, whatever, that the trapeziums haven't accounted for because they're not perfect. It doesn't perfectly follow a trapezium because you don't have trapeziums like this. Well, you definitely don't have them like that. But you don't have trapeziums that are perfect in going sort of, going slightly up one, slightly. They've got to all be the same trapezium. So you can't follow sort of a curvature. So there is going to be a little bit of a difference between that and the actual curve. That's quite obvious, really, but so that filled some time, hey. So when it's sort of curving over like this, that's the best way to think about it. There's underestimation because it is below the line of the curve. But when the trapeziums are above the line of the curve, therefore it's obviously overestimation. And you get overestimation when it's something like this. So if we draw a similar pair of axes, but similar graph obviously, and we get something like this. And then you'll be asked to integrate it again between the lines of A and B, and then you get a trapezium such as above. Now I'm going to do the same sort of thing zoom in on it. So we take it to be 1. So if we draw 1 trapezium, it's going to look something like, I don't know if you can quite see that, but basically we're going to have this little excess bit here. So we're going to be overestimating when it's curving in, but when it's curving over it, so when the trapeziums are under it, then we're going to have underestimation, but when the trapeziums are over the curve, weirdly, we're going to have overestimation. So that's really it for trapezium rule. As I said, it's nothing too much. I did a really quick recap because I do want to fill a video in the C4 category for saying trapezium rule and just giving you a quick insight and recap to it. But if you don't quite get this, and I've not explained it very well because I don't think I have, because I just assumed in this video that you've already watched the C2 version of this, if you've uploaded it, and you're fairly familiar with it, and that was just a recap. Because yeah, it's not a particularly difficult topic, especially compared to what we've already done in C4. So it's just a nice bit of a break, really, to have a quite short video that isn't too much maths involved, intensive. So you can go, as I said, if you don't get that, do go on the C2 link to this C2 video in my channel, and I do go through it a bit better in that video, I personally think. I don't criticise myself. So I'm better than myself. Don't have any other videos that do that, do they? But anyway, so there are some C4 past paper questions to this, which I will be uploading at a later date. Well, probably by the time my computer's decided whether to upload, it'll probably upload at the same time as this video. So I'm sure there'll be another video on my channel that has the past paper questions. You just have to look. But I didn't include them in this video, as I said. I just wanted this to be a short recap. I'm actually waffling on now, but I'll shut myself up in a minute. So it's really just, as I said, just learning the formula. The formula's on the exam sheet anyway, so you don't need to worry about that. So there's not that much to this topic, really. I mean, it might ask you underestimation or overestimation, but on a C4 paper, I very much doubt that. It's more a C2 thing. As I said, most of this topic is mainly a C2 thing, so you'd be lucky if it comes up, because it's a nice break from C4 maths. So anyway, thanks for watching, and any questions or any comments you have on this stuff, either watch the C2 video or comment on my video on this one, and I'll try and help you out. If you let me know some questions that you want me to answer, by all means, please do comment on the video, and I will try and get back to you as soon as I can. Thanks for watching. We'll see you in the next video.